So what if you could fly a fighter jet straight through the Alps? Or what if you could chart the course of a pandemic before it even happens? Or how about witnessing the birth of an entire galaxy? Now, this isn't science fiction. This is the incredible power of simulation. Today, we're going to break down exactly what simulations are and how they let us see our world in ways we honestly never thought possible. For a lot of us, our first real taste of simulation is through entertainment. I mean, just look at this fighter jet simulation. These programs use insanely detailed satellite imagery to recreate the world with a realism that is just breathtaking. You get all the thrill of piloting this high-performance machine, all without ever leaving your chair. And then you've got something like this. It's way simpler, much more stylized. It's all about fun instead of pure, hardcore realism. But here's the thing, and this is the key. This is also a simulation. It's just built for a completely different purpose. And together, these two really show you the massive range of what we're talking about. But simulations are so much more than just a way to have fun. When the stakes get incredibly high, they become absolutely indispensable tools. Okay, so for a professional pilot, a simulation has to go way beyond just what you see. This right here is a full-motion Boeing 737 simulator. The entire cockpit, the whole thing, is mounted on this huge hydraulic platform that moves and rotates. Why? To mimic the actual physical forces of flight. That is absolutely crucial for training pilots how to handle something like severe turbulence or that feeling of disorientation. And that gets to the absolute heart of it, right? Simulations create a safe space to fail. A pilot who's still in training can try a really dangerous landing or experience a total engine failure. They can even crash, and the only consequence is a lesson learned. It's a way to push the boundaries with zero real-world risk. So we've seen a simple little game and a super complex professional trainer. How can they both be called simulations? Well, the answer comes down to one fundamental principle: abstraction. At its core, every simulation is an abstraction. I mean, the real world is infinitely complex. Just think about all the physics happening in a single gust of wind. A simulation doesn't try to copy everything. Instead, it very strategically removes or abstracts away any details that aren't needed for its specific goal. It is all about focusing only on what matters.
And this slide just nails that idea perfectly. On the left, you've got a simulation for an engineer. They don't care about the view from the cockpit. They care about how air flows around the landing gear so they can make it quieter. On the right, a simulation for a pilot. They don't need to see airflow. They need to see the runway. Same exact airplane, two completely different simulations, and each one is perfectly tailored to its purpose.
So now that we get this core rule of abstraction, just focusing on what matters, what happens when we apply that principle to the biggest and the smallest questions we could possibly ask? Well, physicists use simulations to see a world that is completely invisible to us. What you're looking at here is a simulation of a quark-antiquark pair. These are some of the tiniest, most fundamental particles we know of. By modeling these subatomic interactions, scientists can actually test their big theories about the forces that hold our entire universe together. Okay, so we can simulate the unimaginably small. But what about going in the other direction? What's the absolute largest thing we can possibly model? The answer? Entire galaxies. I mean, you have these incredibly ambitious projects, like one called IllustrisTNG, that are building these massive cosmological simulations. They model gravity, gas flows, dark matter, all over billions of virtual years, just to watch universes evolve. They're hoping to create galaxies that look and act just like our own Milky Way, giving us this amazing window into our own cosmic history. From the cosmic, let's bring it all the way back home. Because, some of the most important simulations being run right now are solving urgent problems here on Earth. And they're saving human lives. In the spring of 2020, as the world was grappling with the COVID-19 pandemic, a single chart based on a simulation became one of the most influential pieces of data on the entire planet. It gave world leaders a stark, terrifying glimpse into several different potential futures. This was it. Researchers at Imperial College simulated the spread of the virus. That terrifying black curve, that shows the projected demand for ICU beds with no intervention at all. It just completely overwhelms our capacity. That's that thin red line down at the bottom. The other curves show what would happen with different strategies. For leaders who were facing an impossible choice, this chart was that aha moment. It wasn't just data, it was a clear warning of a catastrophe that could be prevented. And the source material notes that just days after this was published, governments acted.
And it goes beyond pandemics. Simulations are totally transforming one of the most expensive and time-consuming processes in all of modern science: discovering new drugs. The central problem has always been the absolutely astronomical cost.
$5 billion. Just let that number sink in for a second. According to one analysis, that was the staggering average cost for a pharmaceutical company to develop and bring just one new drug to market. And a huge chunk of that money is spent on early research and experiments that, in the end, just fail. So this is where computer-aided drug design comes in. Instead of painstakingly testing thousands of real compounds in a lab, researchers use simulations. They can virtually screen millions of digital molecules, seeing how well they dock with a target, kind of like a key fitting into a lock on a virus protein. This lets them find the most promising candidates to actually pursue in the real world, and it saves an enormous amount of time and money. And if you think this is some far-off, futuristic idea, think again. As the FDA commissioner said all the way back in 2017, this is now an essential, standard part of how modern medicine gets made. Nearly every single new drug application relies on it. So from helping a pilot land a plane safely, to showing us the birth of our own galaxy, to guiding us through a global pandemic and creating life-saving drugs, simulations are this profoundly powerful tool for understanding our past and navigating our future, which really only leaves one question: what should we simulate next?